Okay, so we're going to pick back up with functions and symmetry. Functions that are symmetric with respect to the y-axis, if you remember that's what we were doing yesterday, those are called even functions, okay? An even function is a function that for every x in the domain of f, that just means for any x value, if we plug in a negative x, we're going to get the original function. And that's kind of how the test worked, right? Remember, we plugged in a negative x, and if we got the same thing back, then we knew that that was symmetric with respect to the y-axis. And now we're just going to call that an even function. Functions that are symmetric with respect to the origin are called odd functions. Okay, and that one's kind of easy to remember because origin starts with O and odd starts with O. So origin and odd go together, y-axis and even go together, and there isn't anything for the x-axis symmetry. Now, for every x in the domain of f, when we plugged a negative x into our function, for the function to be symmetric with respect to the origin and be called an odd function, f of negative x needs to equal negative f of x. Okay, and just like the stuff we did before, the best way to do it is to check out a couple examples and then you see how it works. So we're going to look at this function here, x cubed minus 2x. We've got the graph of it right here. And so we're going to start by analyzing the graph. So analyze the graph means say what it looks like. So what does it look like? Okay, it doesn't look like it's symmetric with respect to the x-axis to me. It also doesn't look symmetric with respect to the y-axis, but it does look like it might be symmetric with respect to the origin. Because a lot of times these, curvy ones like this are symmetric with respect to the origin. So I'm going to say it looks like it's symmetric with respect to the origin. So it would be odd if I'm right. And so the way to do that is we need to test it. We're going to test if it's even, odd, or neither. And the good thing about this is they both say to put a negative x into the function. So when you put a negative x in, if you get the original function back, it was even. If you put a negative x in and you get negative of the original function, then it's odd. And you don't have to do 3 different tests like we were doing. So we're going to test, and I always like to write down what I'm testing so that anybody looking at my work later knows what I was doing. I'm going to test if it's odd. And that means I'm going to see if f of negative x negative f of x. And so to do that, I'm just going to start out with my function, which says f of x equals x cubed minus 2x. Now I'm going to come in with negative x. So everywhere that there's an x, I'm going to put negative x. So negative x cubed minus 2 times negative x. And I'm just going to start simplifying this and seeing what it looks like. So negative x cubed is negative x times negative x times negative x. Well, 3 negatives keeps it negative. So that's negative x cubed. Negative 2 times negative x becomes positive 2x. So I look back up at what I'm trying to make this look like, and I see that my signs are wrong. Well, anytime your signs are wrong, that's a good thing, and that's an easy fix. If you factor a negative 1 out, the signs are going to change on everything that you factored that negative 1 out of. And then we have that negative 1 in front, which we really don't need to write the negative 1, we just need the negative. So x cubed minus 2x. And you can see that our f of negative x is the negative of our f of x. So we can say that that worked, and this is an odd function. Let's move down to part B. Part B says f of x equals x to the 4th plus 2, but Part B does not have a graph for us. So before we do anything, we're going to need to graph it. Now, hopefully you realize that this number sitting out here alone by itself is the y-intercept, because any constants in these functions are y-intercepts, because if you plug zeros in for all the x's, all that's left would be this plus 2. So 2 is the y-intercept, and now to graph, we're going to make a small little xy table of values, and I'm going to pick points around this y-intercept because I know that that's a point on the graph, so I know I'm in the ballpark of where I need to be. So I already have this point. I'm going to go over here and see what happens when x is -1. See what happens when x is +1. So I'm going to look. Let's say x is -1 or x is +1. Well, plug in -1. -1 to the fourth is just 1, because 4 negatives makes positive. So it's 1 plus 2, which is 3. And when you plug in a +1 to the fourth, you get the same thing, 1 plus 2, 3 again. So the point -1, 3, and the point 1, 3, I should probably take these little dots I made off of here to make it confusing later. And I'm going to keep checking points around this area. So I'm going to move over and check -2. And I might as well check +2 in this direction. So -2 to the fourth. Well, 2 to the fourth is 16, and 4 negatives would make it a +16. So 16 plus 2, 18. And when I plug in a +2, I'm going to get the same thing. 2 to the fourth is 16 plus 2, 18. So very quickly I realized that this graph is going to get really tall really fast. So I can't even make these points because I don't know where they are. They're so far off the graph. So I get a good idea that this is a very tall parabola, a very skinny parabola that goes up very fast. So now I know what it looks like. And when I know what it looks like, I can make a prediction about the symmetry. And I feel like this is symmetric with respect to the y-axis. So we're going to test to see if it's even. Remember, to test even, we need to see if f of -x equals the original f of x. So I'm going to start with my f of x. I have f of x equals x to the fourth plus 2. And now I'm going to check my f of -x. So -x to the fourth plus 2. Well, we just said over and over when we were picking our points that 4 negatives, so -x times -x times -x times -x, is just going to equal positive. So that's just going to be x to the fourth plus 2. And now we can see that f of x is equal to f of -x, which is what we were testing. So this is an even function. So we're going to go ahead and do example C now. So we have f of x equals 2x cubed plus 3. Well, the first thing we're going to need to do is graph it. And one thing we know immediately about this graph is that the y-intercept is 3. So 1, 2, 3. I know that is part of my graph. So right away, I'm going to pick points around it. So I'm going to start with an x and y table. I'm going to start with -1 and 1 because they're going to be on both sides of where I know this y-intercept is. So I plug in a -1 for x. That gives me -1 cubed, which is still -1, times 2. So -1 times 2 is -2, plus 3 is 1. Now I'm going to plug in +1. +1 cubed is +1. So 1 times 2 is 2. 2 plus 3 is 5. So now I've got -1 and 1. And I've got 1 and +5. So this is a little different looking graph maybe. Maybe it's going to be a parabola that comes over here. Maybe it's going to go upside down like this. I'm not sure. So I'm going to keep picking some points. I'm going to pick -2 and 2 because they're in the vicinity of where I'm working. So I take -2 cubed is negative 8 times 2 is 16. So that's negative 16 plus 3 is negative 13. And then I'm going to check positive 2. Positive 2 cubed is 8 times 2 is 16. 16 plus 3 is 19. So I have negative 2 and 13. That's going to be way down here somewhere. And I have positive 2 and 19. It's going to be way up here off my computer screen somewhere. So very quickly, I know that this is going to be some kind of curve like this. It's going to come up, it's going to go through this point, and then it's going to curve back up that way. So I'm pretty sure this one looks like it's symmetric with respect to the origin. So let's write that down. If it looks like it, right, I could fold it in half and then fold it again on top of itself, and it would match up. So it looks like symmetric with respect to the origin. But when I look at it, I notice it's not going through the origin. So that's a little different to me. So it looks like but it's up high. I'll just say that. I'm writing down what it looks like. I don't know, so I write it down. So I'm going to test. I'm testing if it's symmetric with respect to the origin. So I'm testing if it's odd. So I'm testing whether it's an odd function. And I'm going to see if f of negative x equals negative f of x. So we remember the way to do that is we start with f of x. And that was 2x cubed plus 3. And now we're going to evaluate with negative x. So 2 times negative x cubed plus 3. Remember, we do parentheses and exponents first, so that 2 is not going to do anything right now. So 2, and now we have negative x times negative x times negative x, which is still negative x cubed plus 3. Now we can do something with the 2. So this becomes negative 2x cubed plus 3. And you think, well, that doesn't look exactly like that, but well, we could try that little trick from earlier where we take out a negative 1, right? That usually helps with stuff. So we take out a negative 1 and we get 2x cubed minus 3. Well, that didn't help because it changed that sign to negative. And so we could keep working with this, but what we're going to find is that there's really nothing we can do. So f of negative x does not equal negative f of x. So it's not odd. Now we could test if it was even. I don't have any reason to think that it's even because it doesn't look like it's symmetric with respect to the y-axis. But just to be safe, to test if it's even, we say that f of negative x is going to equal f of x. Well, I don't really need to do that because I already did f of negative x. So what I can do is just kind of look down here and see, do I see anywhere where this 2x cubed plus 3 comes up? Well, it kind of right there, but it has a minus in front. And when I took the negative out, it jacked it all up. So that's not going to work. It's not going to come out. So f of negative x is not going to be equal to f of x. I don't really need to test it. So this f of x is neither odd nor even. Okay, and then we have one more down here. So you go ahead and check this one yourself. Read the whole problem. This is similar to what a test question might be. When it says graph, you need to have a graph. When it says use the algebraic tests for symmetry, you need to use those tests that we did. And then use your findings to determine whether the function is even, odd, or neither. So somewhere, you're going to have to say whether you think this is even, odd, or neither. This is a good practice for you, a good kind of indicator of how well you understand it. So give this a try, and we will talk about it tomorrow.